everybody. I'm Mark Payne. Today I want to begin a series on Apache NiFi anti-patterns. So these are flows that I've seen users creating over and over again, but they don't really make very efficient use of NiFi's design and architecture. So I want to start by looking at some of these different flows, and then we'll discuss some of the weaknesses that they have and how we can redesign these flows to really better utilize NiFi and play to its strengths. So let's get started. So the flow that I want to look at today, I've probably seen a dozen times or more. So the intent of this flow is that we want to ingest some CSV data. In this case, we're pulling it in from a file system using the list file and fetch file processors. This CSV data has four fields in it: customer ID, customer name, purchase total, and purchase time. Once we've ingested that CSV data, we want to do some routing on it. So in this case, we're actually going to pull out any CSV record that has a purchase total of more than $1,000. And if we find any of those, then we're going to send an email to someone. Once we've made that routing decision, we're going to enrich the CSV data. Once we've enriched that data, then we're going to convert that CSV data into JSON. And finally, we're going to write that data out somewhere. So in this case, we're using a put file processor just to put it back to the local file system. So we can go ahead and start this flow, and we'll see the data moving through the system. But if we refresh, we're going to see right away that we have a bottleneck right here with the extract text processor. So if we look at how this processor works, in the configuration, we can see that there's a handful of different regular expressions configured here. I'd really like to avoid using regular expressions if I don't have to, because they're really difficult to write and even more difficult to read and maintain. These regular expressions really are ignoring the fact that our CSV data may actually have quoted or escaped commas in their fields. So it's kind of a quick and dirty way to parse the CSV data, but it's not necessarily correct, and it's pretty expensive to evaluate, which is why we have the bottleneck here. And very much related to this, the split text processor is actually splitting on any new line that it finds. And so this is going to cause a lot of problems if we have CSV data that has quoted new lines within a field. So the first anti-pattern that we have here really deals with treating structured or semi-structured data as if it were unstructured text data and trying to use simple patterns to parse it. We really should be using a proper CSV parser. Now, the reason that this flow is using regular expressions is to promote certain fields from that data into FlowFile attributes. And this allows the user to then route on those attributes and to update the data using the update attribute processor. Then all of these attributes are combined together again into JSON using this attributes to JSON processor. Now, it definitely makes sense to sometimes extract information from a FlowFile's content into an attribute, but what this flow is doing is really blurring the lines between FlowFile content and attributes. It's extracting all of the fields from the content into attributes and then back again. We really want to keep the notions of FlowFile content and FlowFile attributes separate. Attributes are designed to hold key value pairs such as metadata and processing information. They give context to the data. The data itself, though, should remain in the content of the flow file. Creating a bunch of attributes, especially really big attributes, becomes very expensive for NiFi. So blurring the line between FlowFile content and FlowFile attributes is our second anti-pattern that we have here. And the third anti-pattern that we have is this notion here that we see of split text and merge content, or splitting and remerging the data. And again, there are definitely reasons that we might want to do this in a data flow, but we really want to avoid doing this if we can. And to fully understand why we want to avoid it, you really have to understand a lot about NiFi's architecture and how it stores the data in the flow file and content and provenance repositories. And that would be a good topic for another whole video. But for now, just consider that in order for the data to flow through the system, the NiFi framework has to do some level of work. And so if we take a flow file that's a megabyte and contains 10,000 lines of text, and we break that apart into 10,000 different flow files, we've now effectively taken that work that the NiFi framework has to do, and we've multiplied that work by about 10,000. And this also means that the amount of storage space required to store the provenance data is also multiplied by a factor of 10,000. So we end up not being able to hold nearly as much of that provenance data and that lineage information. And it also makes a lineage much harder to follow. So for example, if we take a look at the data provenance of the put file processor, and we look at the lineage for this particular flow file, we'll see that some data was joined together, and if we choose to find its parents, we see a lot of different things going on in this data lineage. So it really makes it difficult to understand exactly what's happening throughout this entire flow. And if we look at the event information for this drop event, we can see a lineage duration of 47.54 seconds. So that means that the latency through the system was about 47.5 seconds for this particular piece of data. So it's not a particularly efficient data flow at all. We should be able to process this data dramatically faster than that. So what can we do differently? Ideally, we'd like to build a flow that's easier to understand and to maintain. We want to process the data much more efficiently. And most importantly, we want to ensure that we're processing the data correctly and using parsers for our data rather than regular expressions that we've come up with and splitting on new lines. So let's take a look at what that would look like. If we move up one level here and we go to our revised approach. All right, so now we get to the fun part of talking about how we can completely redesign this flow. So we're going to start with the same two processors, list file and fetch file, to bring data in. But then all of the processing is going to be dramatically simpler. What we had before was, I think, a combination of about 6 different processors that would be responsible for breaking that data apart, enriching it, doing some routing on it, converting CSV data into JSON, merging it all back together. And in this version of the flow, we're able to get rid of all of those 6 processors and replace it with just these 2 processors that are of type query record. And this processor, out of all of the processors in the entire NiFi distribution, has really got to be my favorite. And yes, I do have favorite processors, and you probably should too. This processor is an absolute beast. And we'll talk about how we can configure it and what it's doing in just a second. But we'll notice that we've got the same output here. If any purchase is more than $1,000, then we're going to go ahead and use a put email processor just like we did before. And the final result is going to be put into the file system using put file, just like we did before. So what we're not doing in this particular flow, though, is using a split text processor to break it apart and remerge it back together. And that's because these query record processors, and any of the record-based processors for that matter, are really designed to take in a stream of records in a single flow file and operate on each of those records independently instead of breaking them apart. And so if we look at query record and look at its configuration, we'll see that it's actually really simple to configure. It has 3 key properties here. A record reader, and that's going to allow us to configure how we actually parse that incoming data. So in this case, we're using a CSV reader. So that incoming data is going to be CSV, and we want to parse it using a proper parser rather than splitting on new line and using regular expressions to find all of the delimiters and pick out the fields that we care about. Instead of doing all of that, we'll just choose a CSV reader and it'll handle all of that for us, and it'll do it according to the CSV specification. So we don't have to worry about our patterns being incorrect. The next thing that we're going to configure here is a record writer. So after we've parsed that data, we're going to run some SQL over that data, and then the results we're going to write back out. So in this case, we're saying that we want to write the result out in CSV also. And then we were going to define what it is that we actually want to do with that data once we've parsed it and before we write it out. So in this case, all we really want to do is we want to pick out any records that have a purchase total of more than 1,000. And so that's what this SQL says. Select asterisk, which means all of the fields from the flow file where the purchase total field is more than $1,000. So if there are any records that match that criteria, they're going to be written out to this critical relationship. And we can see that this critical relationship is again routed to put email. And then we're going to send the original flow file. So regardless of what matched or didn't match in that query record processor, we're going to go ahead and send the original flow file down to the second query record processor. The second query record processor is going to be responsible for, again, parsing CSV data because that was the original relationship, and the data as it came in from the file system was in CSV format. But this time, we want the output to be in JSON because that's what we actually want to go out to our file system. That's what we want the end result to be. So we can just choose a record writer of the JSON record set writer, and that's all we have to really configure. And then we get to choose what SQL we actually want to run over this data in order to transform the data or to choose which fields we care about or which records we care about. In this case, we want to do our enrichment actually right here in line. So we're going to say select asterisk, so select all of the fields. And we also want to select this additional field from FlowFile. This additional field is going to use the expression language to pick out the current date and time. And then we're going to format it using the month, day, year, hour, minute, and second, just like we did in the previous flow. And then we're going to call that new field process time. And that's all we have to really do to select all of the existing fields and then add in this new enrichment field into our flow file. And then we're going to write that data out, like I said, using the JSON record set writer. So this is why I love this processor. It's extremely powerful, it's easy to use, it's easy to configure, and it's extremely efficient. So we talked about how inefficient the previous flow was, and I promised you that this version of the flow was going to be a lot more efficient. So let's take a look and see how much more efficient this actually is. I'm going to click Start, and then I'm going to immediately refresh the results. And we can see that we've already processed almost all of the data. We've now finished processing all of that data within that amount of time. So if we come down here and look at the provenance data for the put file processor, just like we did before, and we look at the event details for this particular drop event, what we saw before was about 47.5 seconds. And with this version of the flow, that time's now been reduced to 0.885 seconds or 885 milliseconds. So we went from about 47, 48 seconds to less than 1 second. So we saw this flow performing about 50 times faster than the previous version of the flow. It's also worth noting, if we then come over here and look at the lineage for this particular flow file, we see a fork event, and we can expand that fork event and we can find its parents. And we can see everything that happened to that flow file. We don't see 100 different children getting forked and then joined back together. It's much easier to look at this lineage and understand exactly what happened to the data all the way through the system. And so there you have it. With this version of the flow, we've eliminated the splitting and the remerging of the data. We've avoided blurring that line between flow file content and flow file attributes. And we've treated our structured and semi-structured data as actual data that can be parsed using a legitimate CSV parser and a JSON record set writer. And this allows us to avoid all of those common mistakes that we're going to make if we're trying to unstructured textual data. And so we've really avoided all of those three anti-patterns with this version of the flow. And as we saw, it's not only a lot simpler to look at and read and understand, but it's dramatically more efficient. So the processing time went from about 47 seconds to about 800 milliseconds. So that's well over an order of magnitude faster. Well, I hope you liked the video and I hope you learned a lot. If so, please do like the video and share it with anybody else you know who may be interested. Thanks a lot for taking the time to watch it.